Hello children, today we are going to discuss about Coulomb's law. By the end of this session, you will be having a clear understanding of what is Coulomb's law and how to write it in its vector form, and also to calculate the force between multiple charges. So we know that there is a force exerted between two charges from our previous classes, that is like charges repel and unlike charges attract. Okay, so repulsion and attraction are the two nature of the force that is exerted between charges. So how was this force exerted was discussed in the previous class. Now here we are going to calculate the magnitude of the force exerted. Magnitude and also the direction using vector form. Magnitude and direction of force. Okay. So we are going to calculate this in this session today. So there were so many experiments that took place to calculate the force between two charges after the invention of charges. And finally, Charles Augustin de Coulomb, he came up with the law that helped us to calculate the force between two charges, which is named as Coulomb's law in his honor. He used a torsion balance for measuring the force between two charged bodies. Torsion balance is nothing. It is a highly sensitive device to measure force. Okay, so torsion balance was used to measure the force between charged bodies. So what he did was, he took two identical spheres having charge, say Q. These are all assumptions. And he varied the distance between the charges. He increased the distance, decreased the distance, and at various points he calculated the amount of force exerted between these two charges. Then what he did was, he kept the distance as constant and varied the charge. Say Q here, then Q here, or Q by 2 here, Q by 2 here. So he did a number of experiments, and finally he came up with a mathematical statement which told that the force between two point charges, okay, force between two point charges. What do you mean by point charges? So point charges are charges whose magnitude is very small compared to the distance between the charges. So point charges, the magnitude of the charges is very small compared to the distance between them. So diagrammatically, the value of R is much greater than the magnitude of this Q. Okay. So he found out that the force between 2 point charges, say Q1 and Q2, so this will be Q1, this will be Q2, is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the two charges. Okay, let us see the law now. So here you can see that there are two charges that are placed at a distance r apart, Q1 and Q2. So the force between these two charges will be proportional to the magnitude, because one charge can be negative, or two charges can be negative, or both can be positive, things like that. So we are taking only the magnitude according to Coulomb. Okay. The force between two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between the two charges, and this force will act along the line joining the two charges. What do you mean by line joining the two charges? Here you can see this is the line that joins the two charges. Okay, so it is acting along the line joining the two charges. So now this proportionality can be removed by using a constant which is known as the constant of proportionality. Here we call the constant as Coulomb's constant. So this can be written as F is equal to K into, now we can combine these two and write it as a single expression as it is shown here. So now I am removing this proportionality and I am writing it as K Q1 Q2 upon R square. Okay. This is the scalar form of Coulomb's law. That also you should keep in mind. Now we have to find out what is this Q and how, what is this K and how to find out the value of this K. Okay. So F is equal to K into Q1, Q2 upon R square. So now experimental analysis helped us to find out that the value of K is equal to 1 by 4 pi epsilon naught. This epsilon naught is the permittivity of free space. Permittivity. What is meant by permittivity? How much force or lines of force it can permit. Okay. Permittivity of free space. And this has a mathematical value which is equal to 8.854 into 10 to the power minus 12 Coulomb square Newton minus 1 meter minus 2. How this unit is derived, I will tell you after some time. As of now, epsilon naught is permittivity of free space and the value of epsilon naught is found out to be 8.854 into 10 power minus 12 Coulomb square Newton minus 1 meter minus 2. Now, the value of this 1 by 4 pi epsilon naught was found out to be equal to 9 into 10 to the power 9. This will also have an SI like unit. Value of K will have an SI unit, that is Newton meter square per Coulomb square. Okay. Now we have to understand how we got this both SI units. You know that F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square, right? Okay. So now first of all, let us, this 1 by 4 pi epsilon naught is taken as K. First we will find out the SI unit for K. Okay. So that is K Q1 Q2 upon R square. So now that is, okay, here you can write F is equal to. So now if you are taking K on one side, this will give you F into R square divided by Q1 Q2 will be equal to K. So what is the SI unit of F? Newton. What is the SI unit of distance? Meter. So R square, meter square. And Q1 is Coulomb, Q2 is Coulomb. So it is per Coulomb square. So this is how you get the SI unit of K as Newton meter square per Coulomb square. Similarly, now you can find out for epsilon naught. Keep epsilon naught, bring this epsilon naught here and bring this F here. Okay. So what happens is Q1, Q2 is in the numerator. So it should be Coulomb square. Right. And R square is in the denominator. So it is meter power minus 2. Similarly, F will be in the denominator. So it is Newton power minus 1. This is how you get the SI unit. Okay. So now, if you take a charge of 1 coulomb, that is Q1 is equal to, Q2 is equal to 1 coulomb and R is equal to 1 meter. What will be the value of F? F will be equal to 1 by 4 pi epsilon naught into 1 upon 1. And what is this value? It will be something like 8.9 something, which is rounded off to 9 into 10 to the power 9 Newton. So the force experienced between two charges, which is having a magnitude of 1 coulomb each, when it is placed at a distance of 1 meter, will experience a repulsive force of 9 into 10 to the power 9 Newton. Force is always measured in Newton, so SI unit of force should be written in Newton. I hope this is clear. Now we shall move on to the vector form of Coulomb's law. Vector form, we know that we are indicating the direction. So there will be a unit vector here to indicate the direction. So two cases are to be considered. In your textbook, it will be two together. Here what we will do is we will separate it and do it so that it is easy for you to understand. So now I have taken two charges and I am going to calculate the force on charge Q2 due to charge Q1. Okay, so force on charge Q2 due to charge Q1. So I am writing it as F21 vector. Force on, so F21 is force on charge Q2 due to Q1. Okay. So now this can be written as F21 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. So what will be this R here? So now see, we know that force on charge Q2 due to Q1. So who is applying force here? Q1. So now Q1 is applying a force which is repelling this Q2 outside, right? So the force is exerted from this point to this point such that it is moved outwards. So the direction will be from 1 to 2. So the direction vector here will be R12 square and write R12 cap. R12 cap is the unit vector which will represent the direction of the force from the charge that exerts the force. Okay. So this is for the first part. That is the force exerted on charge Q2 due to the charge Q1. Okay. And now we will calculate the force exerted on charge Q1 by Q2. So force exerted on charge Q1 by Q2 can be given as F12 vector. F12 vector is force on charge Q1 by Q2. Okay. So F12 will be equal to 1 by 4 pi epsilon naught Q1 Q2 divided by again. So this is who is exerting the charge now? Who is exerting the force now? Q2 is exerting the force on Q1. So the distance will be from 2 to 1. And the unit vector will be R21 cap. Okay. So now what is this R12 vector or what is this R21 vector? So you know that R12 vector will be equal to R. We know that R12 vector is equal to R1 vector minus R2 vector. Similarly, R21 vector is equal to R2 vector minus R1 vector. Okay. So this can also be written as minus of R1 vector minus R2 vector. So now you can understand that this R21 is equal to minus of R12 vector. So you can represent this now what you can write here? F12 can be written as F12 vector 1 by 4 pi epsilon naught Q1 Q2 upon R 21 square. Unit vector can be written as minus R12 cap. So this minus can be taken to the front part. So you get minus 1 by 4 pi epsilon naught Q1 Q2 by R square R12 cap. So this is equal to F of minus F of 21. So the same thing will hold for repulsion also. We will see that a little while later. So F12 will be equal to minus F21 or F21 will be equal to minus F12. This will be the same for both attraction and repulsion. And this is obeying Newton's third law of motion. So now if you wanted to have a better understanding, understanding how these the diagram is being drawn, take a XY plane. XY plane, and let us take charge Q1 here, charge Q2 here. Q1 is at a distance of R1 from the origin and Q2 is at a distance of R2 from the origin. So now the line joining Q1 and Q2, because we know that force is exerted on the line joining between the two charges. So this can be taken as R12. Okay. So now here there will be if the two charges are of the same nature, here there will be a force on Q2 will be repulsion. Okay. So here force on charge Q2 will be F21. Right. Okay. And force on Q1 will be F12. So now from the diagram itself, you can understand that the two charges are opposite, two forces are opposite to each other. Okay. So that is, there is repulsion. Similarly, now here you can see the diagram for attraction. Attraction means this can be positive, this can be negative or vice versa. So they are oppositely natured charges. Right. So again, if you are writing the force, the same expression will hold true. Okay. So force on Q1 due to Q2, you can calculate in the same way, and force on Q2 by Q1, you can calculate. And in both cases, you can see that the force exerted will be opposite to each other. That is F12 vector will be equal to minus of F21 vector. Okay, this is the vector form of Coulomb's law. And surprisingly, this will obey Newton's third law of motion. Another important thing you have to understand is if the two charges are like charges, be it positive positive or negative negative, the product of the two charges Q1 and Q2 will be greater than 0. That is, when Q1 and Q2 is greater than 0, the nature of the charge will be repulsive. And if the two charges are opposite to each other, plus into minus will be minus, right? So minus means it is a negative value. That is Q1, this is 1. Q2 will be less than 0. Product of Q1 and Q2 will be less than 0. So the charges will be unlike charges. Okay. So here it will be attract. So if the two charges are like Q1, the product of Q1 and Q2 will be greater than 0. In that case, the nature of the charge will be repulsive. And if it is unlike charges, the product of Q1 and Q2 will be less than 0. In that case, the nature of the charge will be attract. Okay. So with this, we will move on to the force between multiple charges. So here what we are going to do is, we are going to calculate the force on one charge due to two other charges. Earlier it was one one charge over another charge. Now we are going to calculate the force exerted on a charge by two other charges. Okay. So now let us draw a diagram for that so that it is easy. We'll take a charge Q1 here, another charge Q2 here, and another charge Q3 here. So now we have to mark the distance from the origin. This is your origin. So Q2, the distance between the origin and Q2 can be taken as R2. Q1 and origin is R1. And Q3 and origin is R3. Okay. So now this charge Q2 will exert a force on this charge Q1. This charge Q3 will exert a force on this charge Q1. We are going to calculate the force exerted by the other charges on the charge Q1. Okay. So this force will act in this direction. This force will act in this direction. Resultant according to parallelogram law of vectors will be in this direction. Okay. So this will be F12. This will be F13. 13 means it is Q1, right? So it is F13. So this will be the resultant F. Okay. So now mathematically when you are writing it, you will be calculating F12 or F13 first, then the next one. And finally, you will be adding both to calculate the force on charge Q1. Okay. So this is what superposition principle says. And we will be writing the definition of that after completing the mathematical understanding. So now F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R12 square R12 cap unit vector. F13 will be 1 by 4 pi epsilon naught Q1 Q2 divided by R13 square R13 cap. So now due to these two charges, when you are calculating the force exerted on charge Q1, F1 will be equal to F12 plus F13. That is 1 by 4 pi epsilon naught is common. Take it outside from both the equations. Again, if you can see very clearly, you can understand that Q1 is common in both cases, right? So now Q1, take it outside. So you will get Q2 by R12 square R12 cap plus Q3 by R13 square R13 cap. Okay, this is the expression for calculating the force exerted on charge Q1 by the other two charges Q2 and Q3. So if you wanted to generalize this expression, if there are n number of charges, okay, so the force exerted on the charge 1 due to all the other charges will be F1, it will be equal to F12 plus F13 plus etc. plus F1n. Okay, so generalized expression, if I write, I can write as 1 by 4 pi epsilon naught. Q1 will be same, right? Everywhere. So we can take that Q1 outside. You will get it as summation of I is equal to, because this Q1 is outside, it should the counter should start from 2. 2 to n Qi divided by R1i square R1i cap. And you should understand that the force on a particular charge is unaffected by the presence of other charges. That is Q1, now we calculated the force exerted on Q1, right? Similarly, the charge Q1 will exert a force on Q2 and also on force Q3. But this is not affecting the force experienced by charge Q1. Okay, so that is very important. This force is not affected by the presence of other charges. Q1, Q2, etc. up to Qn. Okay. So by this way, we are going to understand the superposition principle. The statement we will go through, which is nothing but we'll write it here. Superposition principle. It states that in a system of charges, like say Q1, Q2, Q3, etc. till Qn, the total force F1 on the charge Q1 due to all the other charges is the vector sum of forces F1, F2, F3 is F12, F13 till F1. Okay, I'll write it. The total force on the charge Q1 due to all the other charges is the vector sum of forces F12, F13, etc. till F1n. This is superposition principle. Okay. The vector form of Coulomb's law is very important question, which is repeatedly asked for the board exam. Please have a understanding of that. Now, with this understanding, we shall test our knowledge now. Listen the question carefully. The force between two charges is 120 Newton. If the distance between the two charges doubled, what will be the force? You know that F is equal to K into Q1, Q2 upon R square. Now, R is doubled means R becomes equal to 2R. So, now this equation will be K Q1, Q2 divided by 2R the whole square. So, it is 4R square, right? So, K Q1, Q2 by 4R square. So, now K Q1, Q2 by R square is 120 is given in the question. Now, here it is 4R divided by 4 means 120 divided by 4 is 30. So, the answer will be, yes, it is A. 30 Newton will be your answer. Okay, this is the correct answer. Okay. So, write the nature of the force Q1, Q2 greater than 0. So, Q1, Q2 greater than 0 means it is repulsive. We have already discussed this. If the two charges are of the same nature, be it positive, positive or negative, negative, then the nature of the charge will be repulsive. And Q1, Q2 is less than 0 means it is attractive. So that one charge will be opposite in polarity to the other charge. Okay. Coming to the next question. In a medium, the force of attraction between 2 point charges, distance d apart is F. What distance should these be kept apart in the same medium so that the force becomes F by 3 and 3F? Okay. So, the force of attraction at a distance d is F. So, F is equal to, we shall write the equation first, K Q1 Q2 by d square because the distance is given as d. Okay. So, now you have to, you should acquire a force of F by 3. So, the next equation should be F by 3. You have to calculate the distance, right? So, you can take the new distance as d dash square. Now, if you divide this, take this as equation 1, take this as equation 2. So, when you divide F by 3 will be equal to, what will happen? This d dash will come to the numerator. D will be in the denominator, right? F and F gets cancelled, 3 will come to the numerator. So now you will get 3 is equal to D dash square by D square. So 3D square will be your D dash square. Now, but we need only D dash, right? New distance. So new distance, you have to find out the new distance, you need to take the square root. It will be root 3 D is equal to D dash. Okay. Similar way, you have to do it for 3F. So when you are doing, this is for the first part. Okay. This is for the first part. Second part, you need to get 3F, right? So try it in the same way. Your answer should be D by root 3 is equal to D dash. Okay. Check, do it and check if you are able to. If you have any doubts, no, you can send like questions in the comment box so that I will be responding to them.